Okay. Good morning, class, and welcome to this lesson on Momentum 7, an elastic collision example. We will be able to solve for the final velocity of two objects in an elastic collision. If you have not done so, I'm going to show you some equations right now, and you might want to go back and look at video 7a if this is your first time watching this video, because it'll give you some derivations there. Okay, so we have an elastic collision. It is going to be a collision between two objects, okay, M1 and M2. This first object is moving at a speed of 5 meters per second, and this first object weighs 0.250 kilograms. This object is at rest, 0 meters a second, and it weighs 0.8 kilograms. They collide, and afterwards, we need to calculate the velocity of object 1, and we need to calculate the velocity of object 2. Okay? So which way are they going? Which way are they going and how fast are they going? So we have our first equation. We have m1 v1I plus m2 v2I equals m1 v1f plus m2 v2f. So this is our equation right here. Okay? Notice we know m1, m2, m1 and m2. We know v1I and we know v2I. And we don't know this and we don't know this. So therefore we need another equation. But we can first simplify this. We know that this equals 0 because the initial speed is 0. So our new equation is going to be m1 v1I equals m1 v1f plus m2 v2f. Now, what we need to do is use our second equation. v1I minus messed up. v2I equals v2f minus v1f. And like I said before, if you don't know where I got this from, go watch the previous video, Momentum 7a, to figure out where that equation comes from. This is our second equation right here. We have two equations, two unknowns. Let's solve for these ones. We know, and from this equation, we know that the initial speed of object 2 is 0. So we're going to have v1I equals v2f minus v1f. Okay? So all we have to do is now take one of these and try to solve for it. Take one of these and try and solve for it. I'm going to try and solve for v2 final. Why v2 final? It doesn't matter. It could be this one as well. I just noticed that if I add this to both sides, v1I plus v1f equals v2 final. Now, I mean, by adding that, I'm going to have positive signs all the way across, and it's going to be simpler. So let's take this right here and plug it into right there. Okay, so I'll redo this now. m1 v1I equals m1 v1f plus m2 times v1I plus v1f. You will notice now, I'm actually going to keep on going with this. m1 v1I equals m1 v1f. I'm going to distribute this plus m2 v1I plus m2 v1f. Remember, I am trying to solve for this. This is my unknown. Everything else is known. The m's are knowns and v1I is known. So first I'm going to get rid of this term because I know all this, okay? I'm going to move it over here. Minus m2 v1I. So m1 v1I minus m2 v1I equals m1 v1f plus m2 v1f. And you might notice now that I actually have some of the same terms. Okay? I actually have some of the same terms here. On this side, v1i is the same. v1i times m1 minus m2. On this side, v1f is the same. m1 times v1f plus, I messed that up. v1f times m1 plus m2. I'm trying to solve for v1f, so let's divide by m1 plus m2. m1 plus m2. That cancels out, and now I know everything in here. The initial speed is 5 meters a second. The mass of object, did I erase that? What is that supposed to be? That is the mass of object 1 is 0.250 kilograms minus the mass of object 2, which is 0.800 kilograms, over 0.250 kilograms plus 0.800 kilograms. So notice here, the kilograms are going to cancel out, leaving me with meters per second, so I get a velocity. Notice that this one's going to be negative. So my velocity, when I calculate this, turns out to be negative 2.62 meters per second. That means after they collide, object 1 is now going to move backwards with a speed of 2.62 meters per negative 2.62 meters per second. Negative meaning is going to the left. So we now have this whole thing. We have one of them, and now all we have to do is, since we have one, we can now solve for the second one, which is going to be very simple. We just use this equation right here. So V2 final is going to equal V1 initial, 5 meters a second, plus negative 2.62 meters a second, and that means V2 final is going to equal 2.38 positive meters a second. So notice how I have an elastic collision. I have two equations, two unknowns. I plugged in for one equation to solve for the next, and this one's going to be moving at 2.38 meters a second in the positive direction.